Math Day, great day, Math Lead learners! Welcome to Mathematics Lead channel, where we turn your math worries into mastery. I am Crisel Jean M. Magalang, and together let us have fun while learning. This is all about solving problems involving permutations. In this session, you are expected to define and identify the meaning of permutation and their types, solve problems involving permutation using the correct formulas, and appreciate the importance of permutations by recognizing their applications in real-life situations. To begin our lesson, let us start with a short activity. This game is called Permutation Phrase Puzzle. I will show you a scrambled phrase composed of 6 or 7 words, and your task is to arrange them to form a meaningful sentence. Here is your first challenge. These 6 words form a meaningful sentence. What do you think is the correct arrangement? Try to say your answer aloud or guess mentally. The correct answer is I study math with my friends. Notice how changing the order completely changes the meaning. This is exactly what permutations are all about. Ready for the second one? This time, 7 words. Rearrange this to form a sentence related to our topic. The correct arrangement is we solve permutation problems in our class. See how rearranging 7 words gives countless possible orders? That's the power of permutations. And here is your last challenge. 7 words again. What meaningful sentence can you create from this? The correct answer is order is always important in mathematics, and that is the core idea of permutations. Order matters. Great job, everyone! You just rearranged phrases with multiple possible orders. This quick activity proves that when the arrangement changes, the meaning changes. And that brings us to today's lesson, permutations. Alright class, before we give deeper into permutations, let's warm up with a quick word activity. Take a look at this word, Mississippi. What do you notice about this word? Anything interesting about the letters? Exactly! Some letters appear more than once. In fact, M appears once, P appears twice, I appears 4 times, and S appears 4 times. If we tried to arrange all these letters in different ways, do you think we'd get a huge number of possible arrangements? Yes, absolutely. Even with repeated letters, the number of possible arrangements can be surprisingly large. Here's the important idea. In permutations, sometimes all items are different, but sometimes, like in this word, some items repeat. And when things repeat, do you think counting arrangements becomes easier or trickier? Definitely trickier. Repetition changes the way we count because some arrangements might end up looking exactly the same if the repeating letters swap places. Let's move forward to our topic, which is permutation. What is permutation? A permutation is an arrangement of objects in which the order is important. Changing the order creates a different arrangement. For example, the arrangement ABC is different from BCA or CAB, even though the same letters are used. This is the essence of permutations. There are 2 types of permutations that we are going to discuss: permutation without repetition and permutation with repetition. Let's start with the basic permutation formula. This applies when all items are different. What does this formula tell us? It tells us how many ways we can arrange our items selected from n distinct items, considering that order matters. N is equals to total number of items, R means number of items we arrange, and N factorial means product of all numbers from N down to 1. So we divide by N minus R factorial to account for the items we didn't include in the arrangement. This formula is read as N permute R. It is used to find the number of ways to select and arrange R objects out of N total objects. Remember that the factorial symbol means multiplying all whole numbers from the given number down to 1. For example, 5 factorial is equals to 5 times 4 times 3 times 2 times 1 is equals to 120. Now, what if some items repeat? That's when we use a different permutation formula. Total permutations is equals to n factorial over n sub 1 factorial, n sub 2 factorial, and infinite. What do all these symbols mean? N is equals to total number of items, n sub 1, n sub 2 is equals to number of items each repeated item occurs. We divided by the factorials of the repeating items to avoid counting identical arrangements multiple times. So here's what to remember. Use the first formula when all items are different. Use n factorial over n sub 1 factorial, n sub 2 factorial when items repeat. Let us solve a problem involving permutations. So here's example number 1. A class is to select a president, vice president, secretary, and treasurer from 7 class members. How many possible arrangements are there? Earlier, we introduced 2 formulas. So which one should we use here? We use the permutation without repetition formula because all class members are distinct, all positions are distinct, no member is repeated, and lastly, order matters. Since everything is unique, this is what exact scenario where we use. So we have here the given, the n is equal to 7, r is equals to 4. So we simplify the 7 factorials and 3 factorials. So 7 times 6 times 5 times 4 times 3 times 2 times 1 multiplied by 3 times 2 times 1 equals 840. Therefore, there are 840 possible arrangements of class officers. Example number 2. Imagine this. You are organizing a race for 5 friends and you want to know how many ways the gold, silver, and bronze medals can be awarded. Do the order of winners matter? Yes! Gold, silver, and bronze are different, so order matters. Also, each runner can only win 1 medal, so no repetition is allowed. That means we use the permutation without repetition formula. So we have here the n is equals to 5 runners, r is equals to 3 medals. So if we use the formula, we have here the 60 possible ways the top 3 medals can be awarded. Permutations are used in many real-life situations, such as determining seating arrangements, creating secure passwords, organizing events or schedules, arranging books or items in order, and ranking results in competitions. So any scenario where order matters involves permutations. So let's test your understanding with a quick 3 questions activity. Pause the video if you need time to think, then check the answers. Question number 1. A team of 6 friends wants to select a captain, co-captain, and secretary. How many ways can they choose these officers? Think about it. All friends are distinct and no one repeats. What formula should we use? We have here the answer, 120 ways. Question number 2. Arrange the letters in the word pepper. How many unique arrangements are possible? Notice some letters repeat. Which formula do we use? The answer is 60. So there are 60 unique arrangements. Question number 3. Full permutation. You have 4 different books and want to arrange them on a shelf. How many ways can you arrange all of them? All books are distinct. Remember, we're arranging all items. Answer is 4 factorial is equals to 24 ways. Great job! If you got all 3 correct, you're really getting a hang of permutations. Keep practicing with real-life examples around you.